All right. Okay, can you allow me to share my screen, Elizabeth?
I think you should be allowed already.
No.
No? Okay, 1 second.
Maybe make me co-host.
Yeah. All right, ready?
Still not working.
Okay, try again.
Should be good now. All right. Good. Can you hear me and see my screen?
We can hear you, but you're a little bit quiet. So
is it better now?
That's better. Thank you.
Okay. So I'm going to talk about the history of consciousness. So first, I should say that I'm really happy to be here. This looks like a fantastic project. Yeah, so I'm going to talk about the history of consciousness research. So I started being interested in this topic when I wrote my dissertation on the methodological problems that we face when we try to answer some questions associated with consciousness. In particular, I was interested in the ways in which we could solve these three debates that we are currently having right here. The first debate is, does unconscious perception exist? The second debate is about the richness of conscious perception, or whether conscious perception depends on attention. And finally, the final debate is what are the brain processes associated with consciousness? So, you know, my goal was to carry a kind of philosophical analysis of the ways in which we could solve these problems. And so I quickly started looking for the historical origins of these debates. Where is this stuff coming from? And obviously, I had heard that our current research program started in the 90s with the landmark article Towards a Neurobiological Theory of Consciousness by Francis Crick and Christoph Koch. But then, in a sense, you know, we all know that that's wrong, because if we go back in time, we can find statements like this one by Tim Challis in 1978, saying, for the last 10 to 15 years, the explanation of the existence and properties of consciousness has re-emerged as an acceptable and important problem for cognitive theory. That's in 1978, so that's well before the 90s. So I started thinking, you know, that those problems didn't really emerge in the 90s. Instead, they emerged in the 70s. And indeed, if you look what happened in the 70s, research on consciousness was already starting to blossom, both in neuropsychology and cognitive psychology. So for instance, we can mention the work of Roger Sperry and others on split brain patients in the 60s and 70s. Still in the 60s and 70s, the distinction between conscious processing and unconscious processing also became important in the domain of memory, following the work of Brenda Milner. And of course, the phenomenon of blind sight, in which subjects can perform discrimination tasks unconsciously. So this discovery was done in the 70s as well, and led to a lot of debates about unconscious perceptions at the time, and still a debated phenomenon. Okay. So, but then of course we can find debates about consciousness in psychology and neuropsychology well before the 70s. So for instance, if you know the current debate on unconscious perception, actually you can find basically the same arguments against unconscious perception in the 50s and 70s. So there's a fantastic article by Israel Gold-Diamond, and another article which is more well known by Erickson, which gives basically the same arguments as the arguments against unconscious perception that we have today. So, you know, as I started looking for the origins of the debates that we have, I kept pushing the origins of those debates further back in time. And eventually I found that these issues were already debated in the 19th century. So unfortunately, it seems like this history has been pretty much forgotten now. So my goal today is to talk about this forgotten history of consciousness science, and hopefully you'll have a better idea of where all these debates are coming from. Now, so the first thing I have to say is that Freud did not invent the notion of unconscious mind. So here's a picture of a guy who did not invent the unconscious. Unfortunately, a lot of people think that's the case, or at least that he popularized the notion. Among many others, I picked almost randomly. Here's a quote by Gusselderer. Until the time of Freud, there was no proper theoretical framework in which to reject the Cartesian idea of equating mind with consciousness. In other words, consciousness was taken to be the point of division between mind and not mind, the mark of the mental. Now, I think that's completely wrong. And as we will see, many scientists and philosophers already accepted the idea of an unconscious mind, of unconscious processes of the mind well before Freud. So the real story of the unconscious mind begins with the opposition between two philosophical traditions. On the one hand, you have the Cartesian and English traditions, championed by Descartes or John Stuart Mill, for example, and they thought that consciousness is the mark of the mental. Consciousness is the mark of the mental. Everything in the mind is accessible to introspection, so you can know about everything that's happening in your own mind. And as a result, introspection is the fundamental tool allowing us to constitute a scientific psychology. We can observe our own mental states, and that's what will allow us to create a scientific psychology. On the other hand, you have the Leibnizian tradition, represented by Leibniz, of course. And in this tradition, philosophers thought that representationality is the mark of the mental. So the main job of the mind is to represent events happening in the external world. So perception is not always accessible to introspection. According to Leibniz, there are what he calls obscure perceptions. And introspection, as a result, is insufficient to constitute a scientific psychology because introspection doesn't tell you everything that's happening in your mind. There's a lot of stuff happening in your mind that you're not aware of directly by introspection. So the difference between these two traditions was very well summarized by Hamilton, who writes, "The question I refer to is whether the mind exerts energies and is the subject of modifications of neither of which it is conscious. This is the most general expression of a problem which has hardly been mentioned in this country, England, and when it has attracted a passing notice, the supposition of an unconscious action or passion of the mind has been treated as something either unintelligible or absurd. In Germany, on the contrary, it has not only been canvassed, but the alternative which the philosophers of this country have lightly considered as ridiculous have been gravely established as a conclusion which the phenomena not only warrant, but enforce." So the main revolution that Leibniz brings to the table is a kind of conceptual change in the way in which we think about perception. So according to Leibniz, perception is not defined in terms of consciousness. Instead, it is defined as a representational activity. And the crucial point here is that when you define perception as a representational activity, perception does not constitutively involve consciousness. It does not constitutively involve consciousness. And this way of defining perception allows Leibniz to write, for instance, that there are hundreds of marks that force us to judge that there is at every moment an infinity of perceptions in us, unaccompanied by awareness and unaccompanied by reflection. That is an infinity of changes in the soul itself of which we are not aware. And so philosophers and early psychologists in this Leibnizian tradition developed the notion of unconscious processes of the mind. And in particular, Herbart introduced the idea that consciousness is a matter of crossing a threshold. It's a matter of crossing a threshold. So according to Herbart, there is a threshold called the limen, at which perception becomes conscious. And below this threshold, so sublimen, perception is not conscious. So this is where the term subliminal perception comes from. So subliminal perception is a perception below the limen. Now, so this Leibnizian view of the mind is extremely important because it allows us to start the scientific study of consciousness. If activities of the mind are conscious by definition, the question, what makes a perception or thought conscious, doesn't really make much sense. You need the alternative. It should be possible that perception and thought could in principle be unconscious in order for that question to make sense. So in a Leibnizian framework, this question can be taken seriously, and as a result, a sense of consciousness can emerge. So obviously, Leibniz didn't have good empirical data to prove the existence of unconscious perception directly, but despite the absence of direct empirical evidence, this framework became dominant among philosophers and scientists in the 19th century. So, the question is, why did this framework become so popular? And I think the answer is that it became popular because it was extremely fruitful. So by accepting the existence of unconscious processes of the mind, we could explain many phenomena that were very difficult to explain otherwise. So here is a list of phenomena that were explained by postulating unconscious mental processes that's described in 1862 by John Daniel Morrell. He writes, so here's the first phenomenon that you can explain with unconscious processes. After puzzling over a difficult problem a long time and leaving it unsolved, we not infrequently find, on taking it up again, that the materials have rearranged themselves in our minds so that the solution is perfectly easy. So he thought that, this phenomenon was explained by unconscious reasoning. And it's difficult indeed to see how we could explain this stuff without any appeal to unconscious processes. Here's the second phenomenon. One idea will sometimes suggest another, which had, as far as we know, no previous connection with it. So here Morrell thought that the connection between conscious ideas was mediated by unconscious ideas. Third, habits, when fully acquired, will come into operation under proper circumstances quite unconsciously. And finally, here's a fun case. Cases of this kind often occur. We write a letter and dispatch it 2 or 3 days after we remember that we made an error in the statement or spelled a word incorrectly. At the time, the error was committed unconsciously, but by a latent process that is brought perhaps some days after into the sphere of consciousness. Okay, so basically, psychologists and philosophers like Morrell argue that we have to accept the existence of unconscious processes of the mind if we want to make sense of all these cases. And it's because of these cases that unconscious mental processes ended up being accepted as a good scientific construct. So as you can see, this has nothing to do with Freud. In fact, Freud was a baby at the time these discussions were taking place. Now, obviously, at the time, this notion of unconscious mental processes led to a lot of debates, and in particular when it comes to unconscious perception. So one of the main debates was to determine whether perception without attention counts as unconscious perception, whether perception without attention should count as unconscious perception. And I think the main argument against the existence of unconscious perception in this case was formulated very early on by Condillac, so in 1743. And his argument relies on a very important distinction that he draws. He writes, a distinguish between 2 kinds of conscious perception, those that we remember and those that we immediately forget. I think that we are always conscious of the impressions that we receive in the soul, but sometimes those perceptions are so subtle that we forget them immediately. And so he distinguishes between 3 theoretical positions in this debate of whether perception without attention is unconscious perception. The first option is that it's not perception at all. There's no perception without attention. And so because there's no perception, there's no unconscious perception either. The second option is unconscious perception. We perceive unattended objects, but we don't perceive them consciously. And finally, there's what I call the perception overflows memory option, which is that we do perceive unattended objects consciously, but we immediately forget that we did perceive them. And of course, this view is quite similar to Ned Block's view, according to which conscious contents, what you are conscious of, can overflow the limits of memory, in this case, working memory. Okay. And so in the century that follows, if you read the literature, this distinction drawn by Condillac will be used by all those who want to deny the existence of unconscious mental processes. Each time they'll say the same thing. So here's an example where George Henry Lewis uses this distinction in order to deny unconscious action in the case of epilepsy, epileptic seizures. He writes that we forget feelings immediately after they have passed is not an argument against their having been felt. We forget myriads of feelings, even energetic feelings experienced a year ago, a week ago, an hour ago, some of which passed but a minute ago. Visceral sensations, sight, touches are beyond recall. This has been overlooked by writers who declare that certain acts performed during an attack of epilepsy or insanity were performed unconsciously. There is no evidence that the acts were performed unconsciously. All the evidence is against it, but only that afterwards, the agent has no consciousness of having performed them. So it's a deficit in memory, not a deficit in consciousness. Now, a closely related debate was another debate on the richness of conscious perception, which took place at the exact same time. And as you'll see, this debate is also strikingly similar to the debates we're having right now. So in this debate, the question was, how many objects can you consciously perceive at once? How many objects can you consciously perceive at once? How rich is conscious perception? So the first experiments, experiments here, these are not really rigorous experiments, but at least they tried. The first experiments trying to answer this question are performed during the 19th century, most notably by Charles Bonnet, and Hamilton discusses this case. They argue that we cannot perceive more than 6 objects at once, depending on how those objects are grouped. So here's what Hamilton writes. You can easily make the experiment for yourselves, but you must beware of grouping the objects into classes. If you throw a handful of marbles on the floor, you'll find it difficult to view at once more than 6 or 7 at most without confusion. And of course, this conclusion is quite similar to the conclusion that Miller would draw from his evidence about the limits of short-term memory a bit more than 100 years later. So that's a pretty good approximation for people in the 19th century. So on the other hand, so according to people like Hamilton and Charles Bonnet, you can only perceive 6 objects, 6 items at once. On the other hand, some philosophers and early psychologists believe that, that conscious perception is much richer than 6 or 7 items at once. So that's the case for Thomas Laycock, for instance. And as you'll see, he developed an argument that is strikingly similar to Ned Block's argument in our contemporary version of this debate. So the question again is, how many objects can you consciously perceive at once? Here's what he writes. Sir William Hamilton thinks 6, because you may see 6 different marbles at once. This does not, however, seem to meet the question. This does not answer the question. It is not how many objects you may think you see, but how many objects you can be conscious of at once. The letters in a word may all be seen as at once as letters of that word. The question is, are we conscious of each one as a distinct letter at one and the same instant of time? So here's the distinction that Laycock is drawing. He distinguishes between consciousness as feelings and sensations, consciousness as feelings and sensations, and consciousness as knowledge. So he distinguishes between 2 senses of the term conscious. You're conscious in the sense that you have feelings, and you can be conscious in the sense that you know, or you can notice events happening. So that's also, he also called this cognitional consciousness. And so his objection to people like Hamilton and Charles Bonnet was that it's not by asking people what they think they see, which probes cognitional consciousness, that we'll know what they see. consciousness as sensation. Again, here the objection is that people can see more at any given time than what they think they see. In other words, conscious perception overflows the limits of cognition about conscious perception. You may think you see only 6 objects at once, but you actually see, in the sense of consciousness as feeling, more than 6 objects at once. That's the objection. And of course, if you know the current debate about these issues, that's exactly Netblock's argument, or at least quite similar. Now, so all the philosophers and scientists who participated in these debates about unconscious perception and the richness of conscious perception were at least open to empirical arguments and empirical discussions. So you might think that they would appeal to experiments in order to solve these debates. And as far as unconscious perception is concerned, to the best of my knowledge, the first experiment was carried by Peirce and Jastrow in 1884. So in this experiment, they discriminated, so their subjects were themselves, and they discriminated weight differences and provided confidence judgments at the same time. So that's actually quite similar to what we do today. So they discriminated between weight differences and then provided confidence judgments. And they observed that they could successfully discriminate weight differences in conditions in which they reported 0 confidence. Now, there are 2 interpretations of these results. The first interpretation is an interpretation in terms of unconscious perception. You unconsciously perceive the difference in weight, and that's what's supposed to explain that you have 0 confidence. It's because you perceive it, but you perceive it unconsciously, and so you're not confident in your decision. But there's a second interpretation, which is that the weight difference is consciously perceived, so you do perceive the difference in weight, but it fails to give rise to any feeling of confidence. It fails to give rise to any feeling of confidence. So that's a deficit in metacognition, not a deficit in conscious perception. Okay. So from their paper, if you read it, it's not clear at all that Peirce and Jastrow themselves favored the interpretation in terms of unconscious perception, actually. And from reading the literature at the time, it seems to me that this experiment was actually never mentioned. So I'm assuming that most scientists were not aware of it. But even if they were aware of it, I don't think this would have solved the debate anyway, because of those 2 possible interpretations of the results. So, so where do we stand today on these debates? I think it's fair to say that as far as unconscious mental processes are concerned, the idea is now widely accepted. Essentially, we've discovered that in order to explain psychological phenomena, we have no choice but to accept unconscious processes, unconscious mental processes. But things are quite different when it comes to unconscious perception. I think it would be quite difficult to deny that we made quite a lot of progress. For example, we discovered blind sight. We developed the 2 visual streams hypothesis, for instance. But still, the unconscious perception debate is unsolved. So in a survey that was done by Megan Peters and Haquan Lau in 2015, they reported that researchers in cognitive science believe that subliminal perception exists, but they do not believe that this has been convincingly demonstrated in the literature at the same time. And in the same way, we've made significant progress on the issue of the relation between attention and consciousness. For example, we've discovered change blindness in attentional blindness, attentional blink. We've developed nice experimental paradigms, but the debate over the richness of unconscious perception is still unsolved. Okay, so now, before I end, I want to briefly turn to a different debate, which is the debate over the physiological conditions of consciousness. So as you can see from these titles so that's a book by Thomas Laycock, that's an article in Mind by Henry Moseley. You can see from these titles that scientists at the time were already searching for what they called the physiological conditions of consciousness, the physiological conditions of consciousness. So here is what Maudsley wrote, for instance. It is certain that by no exercise of consciousness of which we are capable can we explain what it is in itself. The aim of sober inquiry is therefore to search and, if possible, find out the conditions of consciousness. The conditions, that is to say, under which it arises, varies, sinks, and lapses. Here's another quote from Alexander Herzen. Consciousness is a fundamental, irreducible, unexplainable fact. It would already be a major achievement if we could specify the conditions under which it manifests itself. Why does nervous activity become conscious in certain conditions? We do not know, but we can observe the fact that in some conditions, nervous activity is conscious, while in other conditions, it's not. So the goal is to find out those conditions of consciousness. So we can distinguish very quickly between three main views in this debate. There's what I call the hardcore local view, which says that any kind of nervous activity is sufficient for consciousness, including in the spinal cord. There's the moderate local view, which is that consciousness is generated in the midbrain. So activity in the midbrain is sufficient for consciousness. And then there's the global view, which says that consciousness is generated in the cortex. So this debate really started when people with this case, which is the case of a decapitated frog. That was performed by Pflüger in 1853. So that's a study of the behavior of decapitated frogs. And here is how Faeries describes this case in 1876. When a drop of acetic acid is placed on the thigh of a decapitated frog, the foot of the same size is raised and attempts made with it to rub the part. So that's a decapitated frog. The frog doesn't have a head. On the foot being amputated and the acid applied as before, the animal makes a similar attempt, but failing to reach the point of irritation with the stump, after a few moments of apparent indecision and agitation, raises the other foot and attempts with it to remove the irritant. Okay, so the idea is that this behavior is somewhat flexible even without a head. Here is another case that's described that was described at the time still with those poor decapitated frogs. A brainless frog will swim if dropped in water. It will swim to the surface. But here's the thing. If one impedes the emerging frog by putting an inverted jar in its path, the frog will actually redescend until it can swim out of the jar, and then will swim up to the surface. So that's in a brainless frog. This behavior is observed in a brainless frog. So obviously that's quite impressive for an animal without a head. So the behaviors of those decapitated frogs do seem to be quite flexible. And so at this point, the question was, do these flexible behaviors indicate consciousness? Do these flexible behaviors indicate consciousness? So according to philosophers and early neurophysiologists like Pflüger, Lewis, Schiff, and Foster, if flexible behavior is in general interpreted as indicating consciousness, after all, in everyday life, that's what we seem to do. If I see you behave flexibly in response to some stimulus, I tend to think that you're conscious of it. They say that we should apply the same standard in the case of the decapitated frog. And so we have to conclude that the spinal cord is sufficient for consciousness. Here's what Foster writes. We may thus infer that when the brainless frog is steered by some stimulus to a reflex act, the spinal cord is lit up by a momentary flash of consciousness, coming out of darkness and dying away into darkness again. Others, like Carpenter and Longet, denied consciousness in the spinal cord. Nevertheless, they interpreted complex behaviors in invertebrates without a cortex, as well as decorticated vertebrates, as evidence for consciousness. And so according to them, because of those behaviors, subcortical structures were sufficient for consciousness. And finally, the final view is the view defended by people like Faeries, Huxley, Vulpian, Flourens, and Maudsley. These cases only demonstrated the existence of unconscious purposive behaviors. So these behaviors did not indicate consciousness. You should not interpret them as indicating indicating consciousness. Instead, they just indicated unconscious, complex, flexible behaviors. So that's basically how the debate was structured at the time. And now I want to finish by mentioning arguments that were provided by Faeries in favor of this latter view, which is probably the main view today. So Faeries defends that subcortical activity is not sufficient for consciousness with two main arguments. The first case that he provides is cases of patients with lesions who can report on their conscious experiences. And the second case is a case of electrical stimulation, because Faeries was one of the first scientists to perform electrical stimulations of the brain. So he was a very important neurophysiologist. So here's the first case. He writes, we have experiments of disease which practically detach the hemispheres from their mesencephalic connections and leave thought and speech intact so that we can obtain direct testimony as regards the consciousness of impressions. When this occurs, the individual has absolutely no consciousness of tactile impressions made on the opposite side of his body, however much he may strain his attention to receive them. In the mesencephalon alone, therefore, in the midbrain, therefore, sensory impressions are not correlated with modifications of consciousness. Whence, we must conclude that sensation is a function of the higher centers. Okay, so that's his argument against the idea that activity in the midbrain is sufficient for consciousness. But unfortunately, this argument was not convincing for those who had the extreme local view, because they could say that, in fact, what happens if you have a lesion that prevents the connection between the midbrain and the hemispheres, what happens in this case is that you have now two consciousness, one consciousness in the midbrain and one consciousness in the cortex. So that's the answer they gave. Now, the second argument was based on his pioneering work on electrical stimulation. He reported that stimulations of parietal and temporal lobes caused animals to behave as if they were having visual, tactile, auditory, or olfactory sensations, while stimulations of subcortical areas, including the optic thalamus, did not. And so because of this, he concluded that, that activity in the cerebral cortex may be sufficient for eliciting conscious experiences, while subcortical processes control complex behaviors unconsciously. So we should conclude that all these cases in the frog and in all these cases, all that stuff is just flexible, unconscious behavior. But again, proponents of the local view had a counter-argument. Here's what Lewis writes. We do not consider the center of laughter to be located in the sole of the foot because tickling the sole of the foot causes laughter. What proof is there that the current does not pass through the cortex as through any other conducting medium without exciting its activity? So essentially, the counter-argument here is the following: that the cortex is causally involved in conscious experiences does not mean that it is constitutively involved or sufficient by itself for conscious experiences. And so ultimately, Faeries did not convince proponents of the local view to give up their hypothesis. So that's, he failed to convince them ultimately, even if he had probably the best arguments at the time. All right, so I'll stop here for this debate. So we all know that this debate has not been solved yet. Some still hold the hardcore view, some still hold moderate local views, and some still hold the global view. All right, so
conclusion. Good timing. Last slide. Thanks, Matthias.
So we've seen that the sense of consciousness has a long history of unsolved debates. We've seen, in fact, that we can trace the origins of those debates back to the 19th century. Now, trying to explain why we have not been able to solve these debates would be too long, but I just want to suggest that part of the explanation is that we do not understand the relation between consciousness and metacognition. We don't understand that relation very well. And because of that, for this reason, any purported case of unconscious processing can always be redescribed as a failure of metacognition and reports instead. So when people say, that's unconscious, others will say, no, that's conscious, but you have just a failure of metacognition. And because of that, hypotheses about consciousness are very difficult to test, because you can always reject the hypothesis that some behavior is performed unconsciously and say that instead it's a failure of metacognition, not a failure of consciousness. So ultimately, I think that making progress on these issues will require establishing models of the processes by which we come to know our own mental states. So, okay, I'll stop here. If you want to know more about this stuff, you can read this article that I wrote about consciousness in the 19th century. And with Zhou Ledu and Hakuan Lao, we wrote a paper on the scientific study of consciousness in the 20th century. Right, thank you.
Thank you. Great. That was really, really fascinating, Matthias, and wonderful to have this broad overview of how we got here. So I really enjoyed your talk, and we've got time for some questions. And we've got a question from Ivan Romano. I think I'll read it out. I hope that's okay. So at the end of his question, Ivan says, maybe consciousness and mind are just umbrella terms to explain complex behaviors that we can't understand. So the question really is about what's the relationship between mind and consciousness as terms. But I think that final comment that they're sort of placeholders in explanations of behavior is perhaps the heart of the point. Can you react to that?
Well, I certainly think that we don't have good definitions. But that's not a good objection. So that's something that people often say, that, oh, it's just a matter of definitions. People disagree because they don't have the same definitions. In fact, I think that people have the same definitions. We all understand what consciousness is in the same way. And we don't have a good definition of consciousness, that's true. But the very important point is that if you look at the history of science, definitions, precise definitions in like necessary and sufficient conditions, they come at the end of the scientific inquiry, not at the beginning. In general, we always begin scientific investigations with a kind of broad idea of what we are talking about, of the phenomenon we are investigating, and then we move on to a more substantive, important, precise definition of the terms. Yeah.
Well, that's theory generation. So we start off thinking about something, and if we're lucky, we come up with a theory. The theory often says what the necessary and sufficient conditions are. And there are two questions that I'm going to sort of put together here. So from Astrid and from Benji. So I guess Astrid's question is really asking, this is fascinating, but how does it help us now? So are we, when we're trying to do consciousness science now, should we imagine that the history is a curious detail, or does it actually, can it guide us in what sort of science we're doing now? And perhaps Benji's point is about whether the old 19th century debates about phenomenology and access whether we've really progressed since then in the last 150 years.
Well, so when I wrote the paper, I was quite pessimistic about the idea that we could solve these debates, and my goal was to show that, you know, if those debates really started in the 90s, then it makes sense that we wouldn't have solved them by now, because it's only been like 30 years. Science is slow, and so it's not so surprising. These are difficult problems, so we should not expect them to solve them directly. But if you look at the history of science, and you see that we haven't solved these problems in this very, very long time, maybe this should indicate that maybe there's a conceptual problem somewhere. It's not just a matter of acquiring more data, because throughout history, very smart people have worked on these problems, and they haven't solved those problems. So I'm not completely sure the conclusion we should draw, whether we should draw a kind of optimistic conclusion, because in a sense, on some debates, like the debate of the unconscious mind in general, not unconscious perception, but unconscious mind, we've made a lot of progress. So that's an optimistic conclusion. On other debates, it really seems that the possibility that you can always say that something is not, I think really what this history shows is that it reveals the crucial problems
Yeah.
that we have. The problem is that it's always possible to reject the hypothesis that some behavior is performed unconsciously by saying that, in fact, it is conscious, but you're not measuring it or detecting this conscious state. And this fact is preventing progress somehow, I think.
Yeah, that's always a problem if a theory puts itself beyond testability. That's always a concern. The questions are coming in thick and fast, and I worry that we don't actually have time for all of them. But I want to, I'm struck by Elisa's question about the role of language. So it's interesting that you didn't mention language really in your talk at all. And that's great. But of course, there are whole areas of inquiry and whole areas of philosophy where consciousness is all about language. So perhaps this particular group doesn't have that focus, but could you just give a comment on whether you think that consciousness is fundamentally pre-linguistic?
So there are several waves in the history of consciousness research. At some point, language became more important, and basically consciousness was reportability, just what you can formulate into language, which followed, for example, the work of Gazzaniga and Sperry on split brain, where they would say that what consciousness really is a kind of interpreter that has access to language and can create narratives about your own conscious experiences. I think we've moved on from this paradigm, this way of thinking about consciousness, and now we focus more about on perception, which we think is just in that case, consciousness is just the way your own perception feels. If it's unconscious perception, it doesn't feel like anything. If it's conscious perception, it feels like something. This should not require language. And so this allows, the very nice feature of this is that this allows us to study consciousness in non-human animals. And I think this view was shared by people in the 19th century as well, because they mostly studied non-human animals. For example, all of the stimulation experiments done by Faeries were done on monkeys. And of course, there's the case of the frog and all that.
That's really interesting. And I think I personally agree with your perspective there. And I think sensations are a great place to start. So there are lots of really interesting questions. And I think it would be great to hold them in mind. I think it would also be great to take a very short break, do some star jumps, get something to drink, and then we'll start again in 4 minutes time, when it will be my pleasure to talk about quality of sensations. But I'd just like to say, Matthias, thank you very much for a really great start.
Thank you.
Okay, so I think we should be ready to start again. Our next speaker will be Patrick. He requires little introduction. He's a professor at UCL and works on several topics, including volition and somatosensation. And in his next talk, he will be talking about labeled lines and the quality of sensations.
Oh, great. Thank you very much, Elizabeth. And thank you for chairing. The aim of today's session is really to introduce us to sensory and perceptual aspects of consciousness. So you can think of it as the sensation day. And Elizabeth, please do give me a warning after 30 minutes and stop me after 35. So I'd like to talk about, and now I need to share, don't I? So hold on, so get my share right. Is that good?
Yes, it's good.
Okay, thank you. I'm going to be talking about a really old idea in the history of neuroscience, which has always seemed to me really fundamental to the question of how we approach consciousness, but has slightly fallen out of favor, particularly in psychology. It's not something you hear about much in psychology. It's perhaps more dominant in neuroscience, but it's conceptually extremely interesting. And it's the idea of labeled lines in neuroscience. If you've got a background in philosophy, you'll be familiar with the term qualia. In fact, if you've got a background in consciousness, you'll be familiar with the term qualia. But perhaps the easiest way to think about a quale is that our sensations have a particular quality. There's a particular phenomenal nature that they have. And where does that come from? That's slightly related to the hard problem, but not entirely. I'm going to first of all describe what labeled lines are. I'm going to talk about something that I consider to be a subclass of labeled line theory, which is the local sign theory and the question of the spatial quality of location. So what is it about a sensation which makes it seem like it's there as opposed to there or there or there? So the sensory quality of being located in space. And then if there's time, I'm going to just have some more general theoretical discussion about the challenges to the notion. So the problem, I think, really begins with the action potential. So here is a classic action potential. And what's interesting about the action potential is it's pretty much always the same. So the basic unit of messaging in the nervous system is that an action potential either happens or it doesn't. And somehow this very minimal kind of code, which is even sort of half as rich as the Morse code. In the Morse code, you have short and long signals. In the action potential, in the nervous system code, you just have action potentials. You've only got one element of meaning. But somehow this one element of meaning can come to produce an enormous range of sensory qualities. So here in the unicorn tapestries, this beautiful series of tapestries, which are thought to represent the various different senses. Here, the unicorn is staring at itself in a mirror. So that's the sense of sight, sense of vision. And here, I think, is the sense of touch with the lady touching some objects in a dish. So somehow this one code can produce this very large number of different phenomenal experiences. And how can it do that? It's presumably something to do with the fact that this one code is found in many, many different neurons. So although the code is unitary, the number of neurons using the code is in the billions. And somehow this code is able to produce these phenomenal qualities as a function of the neurons in which the code exists. And the person who first put their finger on this problem was the German physiologist Johannes Muller. The nerves of the senses are not mere passive conductors, but that each peculiar nerve of sense has special power, sensory nerve, each peculiar sensory nerve has special powers or qualities which the exciting causes merely render manifest. Sensation, therefore, consists in the communication to the sensorium. We'll come back to that word later. Not of the quality or state of the external body, but of the condition of the nerves themselves excited by the external cause. So this is the theory which, according to Muller, explains why seeing and hearing are not the same. When I see something, there are trains of action potentials in my optic nerve. When I hear something, there are trains of action potentials in my auditory nerve. The phenomenology is completely different, even though the message is, or the unit of messaging is exactly the same. And Muller thought that this was the explanation of this phenomenal difference between vision and hearing, for example, was nothing to do with the physics of light or the physics of sound, but was due to something about the optic nerve itself and about the acoustic nerve themselves, that they carried different labels when they arrived at the central cognition, what he calls the sensorium, when they reach the seat of perception. They carry some label of the condition of the nerves themselves. So this was called the doctrine of specific nerve energies. You can see why that follows very clearly from the way Muller describes it. It's called labeled line theory more recently. And it's rather confusingly, the same idea goes often in neuroscience by the name place coding. So place coding means that you can understand the information that a neuron carries by looking at which particular neuron it is within the neural network, where it is in the brain, what its afferents are, and how it gets its information. So each action potential must therefore carry some sort of label as it travels along the optic nerve, saying, I'm an optic nerve action potential, or I'm an acoustic nerve action potential. This is really interesting because it raises the big question about how some central organ is able to read these labels. How is it that the sensorium is able to attach to the action potentials coming down a particular afferent neuron, the phenomenal label that gives us our experience of sight, sound, taste, smell, touch, and so on? Now, how are the labeled lines going to work? Well, Muller's original idea was that the label was like an announcement which the afferent action potentials carried to a common sensory association cortex. And now that seems really just like a Cartesian theater. It seems much too homuncular. And the alternative view, which is interesting because I think it's not what Muller thought, is that maybe there's something in the receptor, which is the way to think about the origin of different phenomenal experiences. So we know that our sensory organs involve end receptors, which are excited by specific energies in the external environment. And the specific energy that's transduced by each receptor neuron will lead to each afferent nerve having a distinctive tuning. So I work quite a lot on the sense of touch, and we think of the sense of touch as being somehow unitary. But in somatosensory physiology, we know that in fact there are multiple senses of touch. There are at least 4, and the classic 4 correspond to 4 distinct kinds of receptors that are found in the skin. So here you see outlined in red the various different receptors, the Merkel, Meissner, Pacini, and Ruffini. And these solid black lines indicate a physical stimulus that indents the skin, keeps it indented, and then releases the skin, rather as if you were to touch an object on the back of my hand, press hard, and then release it. And the raster underneath indicates the action potentials. So the Merkel disc has a sustained response throughout the period of indentation, whereas the Meissner only fires when, or only generates action potentials in the afferent neuron during the transient, when the pressure is changing, either at onset or at offset. And the Pacinian and the Ruffini have different patterns of firing again and different receptive fields. So the different kinds of mechanical stimulus on my skin will differentially excite the different receptors, which will then send different trains or different histories, different time series of action potentials to the brain. And this is thought to be the reason why the Merkel disc gives a feeling of steady pressure, the Meissner a feeling of vibration, the Pacinian a feeling of flutter, and the Ruffini a feeling of skin stretch. So these are all easily distinguishable phenomena of touch, which have quite different experience and quite different meaning. And we can see that the differentiation between them comes really from the receptor mechanical response to indentation on the skin and the particular molecular composition of the receptor, which leads to the action potentials of the afferent neuron. So it's not so much that the labels are announced as they reach the cortex, but rather that the labels are already available once you understand the patterns of stimulation in the periphery. So what we might then really want to ask is, how can differently tuned afferents, like these 4 different touch receptors leading to 4 different classes of afferent, how can they produce different sensory qualities? And I want to just throw out 3 possible, but quite different ideas. So one is that a process which I'm just going to label phenomenal differentiation. I think the place where it's perhaps most clearly developed is in vision, where it's sometimes called natural statistics. It's basically a form, I think, of principal components analysis. It's what you can do with big data. And the idea really is that somehow the brain receives lots of action potentials from lots of different afferent neurons, and it's simply doing a principal components analysis to identify the regularities of all the input it gets. And if you do that, what you will find, of course, is that, for example, receptors that are adjacent on the skin or adjacent in the retina will tend to generate similar patterns of afferent action potentials. You'll tend to find that if there's steady pressure, which is transduced by this particular receptor, then they'll almost always be firing in these other receptors as that steady pressure begins to be applied during the transient. And then you'll be able to distinguish between all of the different range of inputs that you get by working effectively, working out the patterns of correlation between different afferent neurons. None of that explains quite why clusters of afferent firing patterns become associated with different phenomenology, but it does explain why, for example, sight is not the same as hearing and not the same as touch, not the same as thermal sensation, not the same as taste and smell. So some PCA-like mechanism could explain why we have different experiences. It couldn't really explain why any of them have any sensory quality. It doesn't solve a hard problem. The second idea here, which I think it goes back to this concept that I had about the molecular and physical composition of the receptor being the basis of differences in experience. That's interesting, but it's incomplete because it requires something like receptor tagging. It requires some way in which the action potential that emanates from a particular receptor can somehow be tagged with the information, I've got a Meissner corpuscle at the end of this afferent, or I've got a Merkel disc at the end of this afferent. Now, I don't know how that would work. There's an idea in neurophysiology of memory called synaptic tagging, which suggests that each individual synapse carries a label which allows it to be selectively reinforced during LTP. Maybe it's not beyond the possibility of molecular neurophysiology that the receptors have exactly the same kind of tagging procedure. There's an enormous amount of activity going on in understanding molecular receptor physiology, and it's absolutely brilliant. It's a site of some of the most exciting work in neuroscience. Doesn't tend to link very clearly to consciousness, even though the papers always begin with an explanation that we have different conscious experience because we have different receptors. So that's just a placeholder for a potential future theory. The third idea here is that maybe the reason for our different sensory experiences is the different motor responses that we make to them. Maybe our different phenomenal experiences have their different phenomenologies, not because of anything in the afferent signal that reaches the brain, but because of something about the efferent signals, which we then make in response to those inputs. Now, a lot of these efferent motor responses to stimuli, well, the easiest way to think about them perhaps is through reflexes. But a lot of our efferent responses to stimuli are remarkably sophisticated, might not have any regularity at all. So there's something very contextual about the way we respond to stimuli. So it's not quite clear how simply associating with the responses is always going to work, but at least for some it does. So let's look at smell, for example. Some smells produce this kind of response and others produce this kind of response. I think everybody can recognize that. And we know that different molecules, airborne molecules, will activate different olfactory receptors. The molecular neurophysiology of the olfactory receptors is really well advanced, and the genetics and molecular composition are really well known. And the wiring of particular receptor classes to centers which control withdraw or approach type responses may be the basis of the phenomenal experience of that really stinks versus, oh, that's lovely. Now, one problem here is that our behavioral responses tend to be pretty minimal relative to the range of different things in the external environment. So the most important feature of motor responses probably is approach or withdraw, exactly as you see here, that you can binarize motor behavior in a way which doesn't seem quite sufficient to capture the astonishing plurality of sensory experience. And for example, there are multiple sensory experiences which we might like and will sniff, and there are certainly multiple experiences that we'll recoil from. So this is just to show that one of the challenges for labeled line theory is that we can see how it will help us to understand functions, neurocognitive functions that can be linked to primary areas. I'm going to come back to topographic maps later, so I don't want to spend a lot of time on that. But labeled line theory might well provide an adequate understanding of why, for example, mechanical sensation on the finger feels like steady pressure, feels like pain, feels like itch, feels like warmth or cold or whatever. But it's rather less clear how it can deal with thought. So at the moment in consciousness, a lot of the theories, I would say, are theories of thought. They don't easily relate to theories of sensation. They have sensory inputs. They're empiricist in that sense. But it's not quite clear how a labeled line for particular thoughts or propositional contents would work in anything like the same way as an afferent pathway. So one of the problems with labeled lines is, how are you going to label these sorts of deeply associative types of connections between higher cortical areas? In primary cortex, we know the afferents, we can see how the label might come in, but it's harder when you get more central. So just to summarize so far, we've got a set of different receptors in our body. We've got a retina, we've got a cochlea, we've got skin receptors, and we can reduce the dimensionality of all the inputs that they get. And this can potentially explain why there are distinct sensory qualities. It can't explain why they're phenomenal. It can't explain why we're conscious of them, perhaps. But there's a real contrast, I think, between the kind of account that you would make of consciousness if you start with receptors and labeled lines, and the kind of sort of non-afferent or mixed or pooling kinds of theories that we see in current cognitive theories of consciousness. And this reminds me of the old idea of Quinean theories of meaning in philosophy, where the concept of a Quinean theory is it forms a holistic, coherent, interconnected whole, and there's no particular bit of connectivity with the outside world which is essential. And it seems to me that something rather similar occurs in the way that we currently think about conscious thought and its relation to the periphery. You could lose a few receptors and you still have a global neuronal workspace. So there's a real contrast between this idea of labeling from receptor-based and from central points of view. And finally, of course, the key point about labeled line theories is they're really interface theories. They're theories which say that the primary sort of aspect of consciousness that we need to care about is the interfacing with the outside world. This contrast, this interface focus contrasts with theories that seem more symbolic or formalist in central cognition. Now, I want to spend a few minutes talking about the idea of local sign. So local sign is a really well-developed debate which has emerged historically over the years in neuroscience, and is still present, although it's not called that anymore. And it's really dealing with a particular question about sensory quality, and it's the question of location. So I'm going to show a few slides. This is a real experiment, not a thought experiment. So look at this slide, fixate the central cross, and just have a look at it for a while, and try and sort of work out what you can see. So look at the central cross, work out what you can see, and then I'm going to change the slide. So here's slide B coming in a moment after a little SOA. So here's slide B. So fixate the central cross and have a really good look at that slide and see what you can see. So I'm just going to show those again in case anybody missed them. They're quite straightforward. So here's A. What do you see? And here's B. And I think I can't see the chat with my current screen setup. So I'm not going to ask anybody what's different between those two slides, but there is something different. So one is, of course, that one slide's labeled A and the other's labeled B. But apart from that, the red dot is in a different place. The red dot is in a different place on slide A. It's there. And on slide B, it's there. So I think that you probably had a sensory experience of there-ness. You had the feeling that the red dot was in a particular location, and the location that it occupied on slide A is not the same as the location that it occupies on slide B. So you can have experiences of location. So what's the difference between slide A and B? The red dot's in a different place. And the point here is that two stimuli that differ only in spatial location are easily discriminable. You could tell I changed the slide, right? And what this means is that there must be some sensory quality that a stimulus has simply in virtue of its spatial location. There must be some there-ness, which that red dot had on slide A, which was not the same there-ness as on slide B. And this is what's called its local sign. Local sign is a sort of a translation word from German, and it's not ideal, but it means the quality of there-ness. Local sign is the quality of there-ness of being in a particular place. Now, it's interesting to point out that this is absolutely fundamental to all of our perception. So here is an image, and here is exactly the same image, and all that's done is that the there-ness has been scrambled. So all that's done is that the sensory qualities of location have been rearranged. Now, note that any given afferent wiring diagram for your retina works exactly the same way, or could work exactly the same way for this input and for this input. So your retina is wired up in a particular way. You've got a topographic map in your visual cortex. It will be functionally equivalent to rearrange that so that this scrambled image looked like the mountain, or this mountain looked like the scrambled image. That's just a sort of wiring convenience and how long you want to make all your interneurons. The information is the same, but the spatial quality of there-ness clearly makes a big difference to your sensory experience. And classically, the way that people explain there-ness is really wrong. So in textbooks, the explanation of there-ness of the ABC locations of the arrow is that they project to the corresponding inverted locations on the retina, and if you're Descartes, to the ventricle. And now we have different sort of models, and we say that the locations on the skin project to the somatosensory homunculus. And this is really not an explanation of there-ness. This is explaining the there-ness on the skin in terms of there-ness in the brain. It's deferring the explanation. It's got giving the explanation, and it really risks being hand-waving or even circular. And this was really sort of brought out to me when I read this book by Théodule Ribot, who wrote a very useful primer in French on what German psychology had been doing in the 19th century. And my French reading is much better than my German reading, and reading Lotze and Wundt, who are the original German thinkers, is pretty hard, and Ribot explains it really nicely. And he points out that in order to explain space, people always use spatial ideas which are already contained in the explanandum. So most explanations are circular. We explain the perception of space on the skin or on the retina by the location of the active neuron in the visual cortex. So you're really not providing an explanation that's sufficiently reductive. So to avoid circular explanations, we have to have some reductive explanation, which explains the sensory quality of awareness in terms of something which is not itself spatial, which is non-extensive. We need to explain extensive things in terms of non-extensive things. And the idea, which I think was formulated most clearly by Lotze, it's present also in Helmholtz, it was made, I think, coherent by Wundt, is interesting. It's also actually present in the figure by Descartes. So maybe the explanation of why A, B, and C have different sensory qualities is the different movements that you would need to make if you were to point at B or point at A or point at C. So the motor commands to the muscles to orient towards different locations in space explains why the sensory quality of a stimulus being there is different from it being there or there or there. And the reason why this is a reductive explanation is that this extensive quality of awareness of space is explained in terms of the intensity of the motor command. To point to a point high up, I contract my muscles more than if I point to a point which is lower down. Okay, so by varying the intensity of the motor command to the biceps, I can move to different locations, and thus I can associate a different motor quality to a different sensory quality. So this is the idea that space perception is based on movement, and the sensory quality of awareness is really intimately linked or derives from the movements that you make to move there. Now, we've already seen, I didn't know that lovely spinal frog experiment that you showed, Matthias. I didn't know that particular one, but here's effectively the same experiment done by Emilio Bizzi and Simon Gister and Fernando Musarivaldi over 100 years later, and now they're using sort of richer descriptions, and they're showing the vector force field in the muscles that the frog uses to rub the irritant or to push away an intrusive stimulus. And the idea is that there's a beautiful pattern of motor responses as a function of the location of stimulation on the frog's leg. So the relation between the location stimulated on the receptor surface and the organization of the motor response, provided in this case by the spinal reflexes, would be the basis of spatial perception of the quality of awareness in the frog. And the same sort of idea that the motor basis of spatial perception is fundamental occurs both in visual perception and here in place cells. So we hear a lot at the moment in neuroscience about coding a place in the hippocampus. There's some fantastic work. Here's the original place cell work by O'Keefe. And how does the rat know where it is in space? It knows where it is in space because of its movement. So the rat could rely on visual landmarks, but even if you take the landmarks away, you still get a place cell firing when the rat is in a particular location within its arena. And the idea is that the rat is doing something like counting its steps or integrating linear acceleration as it moves, and it can thus work out where it is. So here's a nice philosophical quote from Evans. A one-dimensional space may be constructed out of any experience, as long as the experience exhibits such order and regularity that its course can be seen as simultaneously due to the way the world is laid out and to the subject's continuous motion through it. Here's so you have this fundamental notion of psychology going right back to Helmholtz. I happen to be very interested in tactile space, and interestingly, the 19th century theory cites two examples to indicate why space is based on movement. One is the example of making an orienting saccadic eye movement towards a visual object, rather like the red dots that I showed you on slides A and B. The other example that they very nicely give is just like the frog experiment. If I have a mosquito that lands on my skin, I will be able to make a movement of my other hand to kill the mosquito. And the spatial perception of the mosquito's there-ness is thought to derive from my capacity to make a correctly organized motor command to that location. So what's interesting about this motor theory of space perception is that it's pervasive. We assume it, and it's really scarcely tested. I think in the saccadic eye movement literature, and particularly around saccadic adaptation, it's relatively well tested. In the case of other sensory qualities, particularly on the skin, particularly touch, it's not tested at all. So the perception of there-ness, really, the idea that there-ness derives entirely from motor control is something which, well, we're trying to test in my lab, but I'm not going to try to talk about any experimental work at the moment.
5 minutes, Patrick.
That's great timing, because I should be able to finish in 5 minutes. I just want to end with a few questions around labeled line theories. It's very, very open, perhaps neurophysiologically informed philosophical debate, we could call it. So one of the first things that we clearly need to know, if there are labeled lines, is we need to know at what level is a label written and at what label is it read. And here are just some examples of this idea of labels being written and read. So let's think just for the moment about the sensory neurons and the quality of sensation. So I'm leaving aside space and local signs now. I'm going back to things like modalities and sensory qualities. So let's consider the case where you have two afferent neurons which both send projections towards something like a brain, and I've shown those by these two arrows here. And let's imagine that somehow these the action potentials in these afferent neurons are labeled, and I don't know where they're labeled. They're labeled somewhere on their journey from the periphery to the center. And let's imagine that there's some unknown structure or zone in the brain which reads the labels. So that's shown by this horizontal line. So this is a sort of classical view which would give us 5 senses. So this afferent neuron might come from my retina and this one from my cochlea. And if we ask people how many qualities are you perceiving, they would probably say 2, because there are 2 labels being read out. But there are lots of really interesting cases where we can test labeling theories by seeing how many qualities are perceived as a function of the underlying wiring. So for example, if you have a situation where 2 afferent neurons converge before the label is read out, then if you ask people how many qualities they perceive, they'll say 1. They might say there's only one thing there, or it's only something I see, I don't also hear it. Or they might say, if it was a question of location, they might say there's one thing rather than 2. Often you get inhibitory interactions between afferent neurons, and this might lead to the fact that you might only perceive one quality even though 2 receptors are activated. So a beautiful example of this is the relationship between touch and pain. So it's well known that that touch inhibits pain in the spinal cord. This is what's called gait theory, and it was developed by Pat Wall. If you hurt yourself, hold on to your wound tightly, and then you will feel less pain. So when somebody comes along and says, excuse me, how many sensory qualities do you perceive? You'll say only 1. I can only feel the touch. I can't feel the pain. If, on the other hand, you have some sort of exuberant arborization, which happens after the label readout, what you might find is that a single afferent neuron will produce a single sensory quality. But if the arborization happens before the readout, then people will say, oh, I experienced 2 sensory qualities, even though only one afferent is present. And this might perhaps be what's happening in synesthesia. So we can speculate about things which are just so fundamental to our mental life that it's actually hard to think about them. But how many sensory qualities are there? And can we explain how many sensory qualities there are in terms of the idea that there are labeled lines in the periphery which are read out at a particular location? Now, one clue about where that location of reading is comes from metamers. And metamers are composite stimuli that are indistinguishable. So here we have two dimensions, and you can discriminate. Right, so what we're going to do here, see if I can get this right. So with metamers, you have a complex stimulus which is indistinguishable from another stimulus, even though the components are quite different. So people, for example, might be able to distinguish the red composite from the green composite, and they would perform exactly identically if the red composite was made from the solid red. They can distinguish that from the solid green, and there's no difference in their performance compared to if they have the hollow red and the hollow green. So these two reds are therefore indistinguishable, they're metamers. And what this would mean is that the sensory quality label must be read after the components are combined. So the two reds would need to be combined, the two greens would be combined, and you don't have access to the individual components. I'm sorry, I slightly mungled that. Comment. You can't distinguish the red from the green, and you can't recover the individual components. So what this might suggest is that the labeling is not only done at the receptor level, but it's also done at this higher convergent level. Okay, so I'm running out of time. Here's some more on metamers, which are best understood for color perception, but seem also to apply for smell. So you can get particular combinations of smells which will have a particular sensory quality, but you can make that sensory quality with two different combinations. You can use A1 and B1 or A2 and B2, and you can make the same composite smell. I've talked a little bit about neurons in non-primary areas when we're talking about association cortex. So I'm just going to end with a couple of slides on what we might think about labeled lines. So labeled line theory is unusual because it provides a causal and mechanistic theory of conscious experience. I think there aren't many of those. I think one of the strengths of labeled lines is its root in mechanistic sensory neurophysiology. And it's obviously got a strong empiricist feel because it's got strong links to sensory input, and if you believe local sign theories, at least to motor outputs. The idea of a label is, of course, metaphysically and ontologically doubtful. So how can you see the label? What is it, given that the only message carried in the nervous system is action potentials? Maybe labels should just be considered as a metaphor for multivariate discriminability, for the kind of PCA that I was talking about, which would allow us to make sense of the blooming, buzzing confusion that reaches our consciousness. And this idea may work pretty well for primary sensory experiences, and even for feature detectors like motion detectors and so on. But it doesn't seem as though it could help us with conscious thought. It doesn't seem it could help us with abstract ideas and complex responses. And it's not quite clear how it can account for a lot of the features of central cognition, the Quinean features like mixed selectivity and flexible classification. So it's useful to think about some experiments, and the strong prediction of labeled line theory is that if you're conscious of an event, you must know the receptor it comes from, because the receptor label is self-intimating. It's attached to the afferent action potential, and it's automatically read out. And various people will sort of say that sensory substitution and synesthesia invalidate labeled line theories. I don't think they really do. I think what we clearly need is a stimulus which is above threshold, but where the observer cannot tell the quality of the stimulus above chance. Suppose you have a stimulus on your skin, but the temperature changes. You know the temperature changes. You feel that. You respond that in an STT task. But if you can't tell whether it's got colder or warmer, then you won't know whether the cold afferent receptors or the warm afferent receptors in your skin have been activated. If you can tell that there's a smell, but you don't know whether it's roses or whether it's ammonia, then you don't know its sensory quality. So I think it would be interesting to do experiments like that, because if you found that result, it would rule out the labeled line idea of a self-intimating label. Now, thanks very much for your attention. I haven't been looking at the chat, but I'm hoping, Elizabeth, that you can read out anything that's there or field some questions.
Yes, thanks, Patrick, for the nice talk. And we do have a question by Astrid in the chat, which is about the there-ness argument. And she asks, do we need an explanation that distinguishes between egocentric and allocentric spatial information? Are there two different aspects of there-ness?
Yeah, thanks, Astrid. That's a really good question. And I would say, I probably want to say no, just for simplicity. I think one of the nice things about local sign theory is that it can explain lots of different spatial phenomena of location by reducing them to the appropriate motor response. So for something like location in egocentric space, how am I going to make the motor response to the location in egocentric space? Well, if it's a flash of light, I'm going to saccade to it. And if it's a mosquito, I'm going to reach for it. So the egocentricity is simply the kind of motor response that I make to that kind of stimulus. If it's something more like making my way to the mountains as the summer approaches to get green grass, which I guess you would think of as, well, it's certainly an action in navigational space, I'm going to have to walk. And that's a different motor response. But the basic concept that the specific spatial quality of where something is can be explained in terms of the movement that you need to make to interact with that object, to orient towards that object, I think works equally well for egocentric space, where you're typically making saccadic and manual motor responses, and for navigational space. So I would regard, in fact, as a strength of local sign theory, that differences in spatial frame of reference don't require any sort of ontological category of frame of reference. They're just explained in terms of different motor responses.
Great, thanks. And we have a comment by Lucia Maloney in the chat with a reference to to a paper by Tononi's group. I can rephrase the question. She says that in this interesting reference, their account of there-ness does not resort to movement or any representation outside the world to experience space. And it would be interesting to hear your thoughts on this other interpretation.
Lucia, I'm going to express read the article and try to get back to you in the chat on that, maybe during the lunch break. I think that's really interesting. I think the questions we would have to ask, and I haven't read the article yet, would be, is it really non-circular? So one's probably looking for a reductive kind of explanation if one can. And I guess the other thing, which I didn't really consider in the case of space, is whether, multi-dimensional, multivariate data dimension reduction will do the job. So I said that I thought PCA might be the solution to why there are multiple sensory modalities, or phenomenal experiences corresponding to multiple sensory modalities. It's possible that you could explain space in the same way, in which case it's all just PCA. But I'll read the article. Thank you for the reference, and I'll try and get back to you.
And I think we don't have any more questions in the chat at the moment. Lucia saying thank you, cool, and she will wait for your response. I think I will take the chance to take the last question. No, there we go. We have another question, so I will ask you later, Patrick. Benji is asking at the moment, is labeled line theory compatible with sensory motor contingency theory? It seems that they're similar, but sensory motor contingency theory claims the point at which different modalities are distinguished is in the interaction of senses and physical environment, rather than at the receptor level.
I think that's a great question, Benji. The real question is, where does the label come from? Where is it written, and where is it read? It can clearly be associated with a motor response. So I think the big contribution that Wilhelm Wundt made was to consider that the local sign is not something in the afferent sensation, but it's really the combined, the dyad, the association between the afferent and the efferent. So that sounds a little bit like sensory motor contingency theory. Send me the reference that you would say defines a sensory motor contingency. I'd be interested to look at it. I think the two interesting contenders have, and this is perhaps interesting also from the point of view of metacognition, So we do have different sensory qualities for different sensory inputs. So cold does not feel the same as warm. I take that example because there's this rather interesting paradoxical feature of our physiology that we don't sense a unipolar dimension of temperature directly. Rather, we have two different classes of receptor, one for cold and one for warm. So that leads to some quite interesting things when you activate them both at the same time, which shouldn't happen in the physical world, but it can happen in our bodies and in our brains. So I'm going to use cold and warm as an example where you've got these distinctive two different classes of receptors, but of course you've also got two different classes of responses controlled by the autonomic nervous system to cold and warmth. And I think the real challenge, perhaps for metacognition, is what does the system know? Does the system know anything about the receptor of origin? Is there any kind of self-knowledge built into our nervous system? Or is that actually the wrong way to think about it? That's a sort of metacognitive view of labeling, that you can label the receptors of origin. Another view, which is perhaps more strongly rooted in reflex physiology, is that you don't know anything about the receptor of origin, but the receptor of origin is hardwired to a particular class of effectors. In the case of cold and warm, they're probably not motor effectors, they're probably different kinds of effectors, which provide the homeostatic responses. If you want to call that interaction of the senses and the physical environment, that's fine, but I prefer to think it's physiologically. And I think the real question is, how can central cognition cope with this wide variety of phenomenal experiences when their original evolutionary origin looks like it's in dedicated, hardwired, low-level reflex circuitry? And I don't think anybody's really got an explanation of that. Maybe that's another way of invoking the hard problem. But Benji, send me the reference. I'd be pleased to see it.
Thanks, Patrick. I think there's another couple of questions in the chat, but we are out of time. So I say maybe take them in the Gathertown cafes.
That would be great.
So we will continue with the session, with the talks in the afternoon in 45 minutes here in this same Zoom chat. And in the meantime, there's a Gathertown cafe where I would invite you to go and chat to the other attendees. And see you in 45 minutes.
Thanks very much. Enjoy lunch.